Greetings and welcome to everyone. Welcome to another episode, and in this episode we will be discussing some terminology, and the terminology specifically that we will be discussing are factors, multiples, prime numbers and composite numbers. Then let's start off with understanding our first terminology, and the first term we will discuss is factors. Right? So what is a factor of a number? A factor of a number basically refers to all of the numbers which can divide perfectly into that specific number. When we think about what it means to divide perfectly into a number, simply it means that the factors of a number, those numbers should divide into that specific number without leaving a remainder. For example, when we think about the factors of the number 20, for example, let's think about the factors of the number 20. Then when we think about the factors of the number 20, we know we can ask ourselves, what are the numbers that can divide perfectly into the number 20 without leaving a remainder? Then I know 1 times 20 is 20. 2 times 10 is 20. Well, 3 can multiply, right, by something to give me 20. Then I know 4 times 5 will give me 20. Then these are basically the factors, right, of the number 20. Then the factors of the number 20, if I had to write them down, it would be 1, 2, 4, 5, 10, and 20. Right? Then these represent the factors of the number 20. These are all numbers that I can divide 20 by, and if I take these numbers and I use 20 to be divided by these specific numbers within the set, then it's always going to give me a number that doesn't have a remainder, that doesn't have some decimals attached to it, a whole number without a remainder. Yes, so I hope that's very, very clear. Then secondly, so this will be our first term. Then secondly, when we think about the multiple of a number, very simply, the multiple of a number are all of the numbers which that number can divide into without leaving a remainder, right? So when we think about this, once again, we can think about the number 20, right? 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. 20 times 5 is 100. 20 times 6 is 120. Then you can multiply 20 by many more numbers, and ultimately you can multiply 20 by an infinite amount of numbers, and obviously that will continue to be multiplied on and on, right? So if they asked for, please give me the first 6 multiples of the number 20, right, then I would say, okay, the first 6 multiples of the number 20 would be 20, 40, 60, 80, 100, and 120 as the first 6 multiples, right? The first 6 multiples of your number 20. That's really, really important. So once again, the multiple of a number refers to all of the numbers which that number can divide into without leaving a remainder. Yes. Then moving on from that, what we can come to understand next is prime numbers. We can understand prime numbers. Then what exactly are prime numbers? Very simply, prime numbers are natural numbers that are greater than 1, right? So prime numbers are, they are natural numbers greater than 1, and they only have 2 factors. And these 2 factors are the number 1 and itself. So when we think about examples of prime numbers, we can think about the number 2, the number 3, the number 5. So these are prime numbers, a set of prime numbers: 2, 3, 5, 7, 9, 10, 11, 13, 17, and we can go on and on and on, right? But when we think about what's common between 2, 3, 5, 7, 11, if I take any of these numbers, then actually the only numbers that can give me these specific numbers are 1 and itself. If I want something to be multiplied together to give me the number 2, I only have 1 times 2 is 2. When I think about 1 times 3, it gives me 3. When I think about the kind of numbers that can give me the number 4, it would be 1 times 4, or it would be 2 times 2. When I think about the number 5, the only thing that can give me the number 5 is 1 times 5. When I think about the number 6, what can give me 6? It's either 1 times 6, or it can be 3, or it can be 3 times 2. When I think about the number 7, what can give me the number 7? Only 1 times 7. Then when I think about the number 8, what can give me the number 8? It's either 1 times 8 or 4 times 2, right? Let me just put that in another color. Or 4 times 2. Then when I think about the number 9, what can give me the number 9? It's either 1 times 9 or it's 3 times 3. Then again, if I think about the number 10, what can give me 10? It's 1 times 2 or, not 1 times 2, 1 times 10, or it can be 5 times 2. When I think about the number 11, what can give me the number 11? It's only 1 times 11. When I think about the number 12, what can give me the number 12? It's 1 times 12, or 6 times 2, or 3 times 4. Then again, when I think about the number 13, what can give me 13? Just 1 times 13. Then basically what we see is a pattern, right? A pattern. And we can identify and see that the instances where a specific number can only have two factors, meaning only one, right? Only the number one and itself can give me that specific number. Then when we think about 2, 3, 5, 7, 11, 13, we can do this trend on and on. If I identify a specific number that can only be multiplied to get that number, what can only be multiplied is 1 in itself, then that will give me a prime number. Because if I want to know what that number is divisible by, what are the factors of that specific number, it will only be the number 1 and itself. Then through this, you can identify all of this, right? And then you will be able to identify which one are your prime numbers, right? Which would be this, and you can go on and continue to identify them. So if someone had to ask you what are the first 6 prime numbers, then what would you do? You'd say, okay, the first 6 prime numbers would be 2, 3, 5, 7, 11, and 13. Then once again, someone might ask, but Ro, shouldn't 0 and 1 be considered as prime number? No, they aren't, right? So 0 and 1 are very special, and basically the rule is that they are not considered as prime numbers. Yes, because in order for something to be a prime number, it must be divisible. It must be divisible by 1 and itself. Yes. And of course, the number 1 is already 1, right? So moving on from that, what we can discuss next is composite numbers. So when we think about composite numbers, largely they are the opposite of prime numbers, right? So when we think about a composite number is basically a number which has more than 2 factors, right? So it's a number with more than 2 factors. A number with more than 2 factors. And of course, it also still needs to be a natural number greater than 1, right? So when you think about it, composite numbers must be natural numbers greater than 1, of which they have more than 2 factors, right? Or you could consider them as natural numbers greater than 1 that are not prime numbers, excluding 0 and 1. I hope that makes sense, right? Then in the same way, let's think about some composite numbers. Then back when we did our calculation, and maybe I can do it once again for us. So when I think about the number 2, 1 times 2 gives me 2, 1 times 3 gives me 3. If I think about the number 4, it's either 1 times 4 or it's 2 times 2. And then when I think about the number 5, only 1 times 5. Think about the number 6, it's either 1 times 6 or it's 3 times 2. When I think about the number 7, it's 1 times 7. When I think about the number 8, it's either 1 times 8 or 4 times 2, sorry, let me just write that in a different color. 4 times 2. And then when I think about the number 9, it's either 1 times 9 or it's 3 times 3. Then when I think about the number 10, it's either 1 times 10 or 5 times 2. And we can go on and on and on, right? But when you think about this, for example, if you can identify the composite numbers, then again, every single natural number that is greater than 1 and has more than 2 factors, which are these numbers? Then let's think about the number 2. The number 2 only has 2 factors, so it's not a composite number. Number 3 has only 2 factors, so all of these are natural numbers greater than 1, but now we're just focusing on the factors now. 3 only has 2 factors, not a composite number. 4 has more than 2 factors, 1, 4, and 2, right? So it is a composite number. 5 only has 2 factors, so it is not a composite number, right? Then when we look at the number 6, it has more than 2 factors. It has 1, 6, 3, and 2, so it is a composite number. 7, it only has 2 factors, right? 8, the number 8 has more than 2 factors, 1, 8, 4, and 2, so it's a composite number. 9 as well has more than 2 factors, 1, 9, and 3. And then when we think about the number 10, it has more than 2 factors, 1, 10, 5, and 2, so it is a composite number, right? So if someone asked you, please give me the first 5 composite numbers, you'd be like, okay, the first 5 composite numbers would be 4, 6, 8, 9, 10. First 5 composite numbers. So this is really, really good. So now that we have this basic knowledge and understanding, and just a disclaimer, let's put this like this. Disclaimer, important disclaimer, right? Important disclaimer is that 0 and 1 are neither prime nor composite. This is really important, so please do remember that, right? Yes, please do remember that. Then when we look at some examples that we can think about, remember our very first list when we looked at what are the factors of 20. And we took out the factors and we saw it's 1, 2, 4, 5, 10, and 20. Then if someone said, okay, please give me the composite factors of 20, then what would that be? Then you'd look at your list and identify, oh, okay, I know 4 is composite, 10 is composite, and 20 is composite. Then it would be 4, 10, and 20. If someone asked me, please give me the prime factors of 20, then what would that be? It would be 2, it would be 5. So I put 2 and 5. If someone asks me, please give me the even factors of 20, right? Even meaning this number is divisible by 2 without leaving a remainder, right? Then what would that be? It would be 2, 10, and 20. If someone said, okay, sorry, I left out a number there, so it would be 2, 4, 10, and 20. Then if someone asked, please give me the, let me look for another color here, please give me the odd, sorry about that. If someone asked me, please give me the odd factors of 20, then what would I give them? I'd give them, sorry about that, I give them 1, 5, yes, 1 and 5, right? 1 and 5, yes. Then thank you so much, everyone, for our very first session regarding the terminology of various terms. Please do like and subscribe, and if this is really beneficial to you, please do recommend it to someone else. And then in our next episode, we will be discussing the ladder method. Thank you.